Suppose this is, let's say, a 100 ohm resistor connected with a cell of internal resistance, let's say 5 ohm and EMF 21 volt. Okay. If the voltage across 100 ohm resistor is measured using voltmeter of resistance, okay, 500 ohm, 500 400, find the measured voltage with the reading and the error in percent. ઘણા દિવસ આવ્યો ઓલ વેલ હવે આવવાનું કે આજે જ આવ્યો ટીચર્સ ડે જોવા હું તમને આખા સમજો ખાલી ફોર્મ્યુલા છે પછી દવાની વાત મે ક્વેશ્ચન લખો સોલ્વ કેવી રીતે કરીશ સમજો ચક્કર આવે ઊંઘ આવે એક વાત કરી फटाफट कर धीमे धीमे रेजिस्टर बनावे So if you want to find the reading of the voltmeter, first of all we have to attach a voltmeter. કર્યું કે નહીં attach? કેવી રીતે attach કર્યું? parallel માં કરવાનું ને બરાબર ને પછી એનું શું ફાઇન્ડ આઉટ બધાનું equivalent resistance. So we can find current and then we can find the voltage for this. બરાબર ને બરોબર જલ્દી જરૂર નથી ખાલી b. So the circuit where you actually measure would look like this. Yes or no? Okay?
Yes.
Clear or not clear?
Yes.
Okay. How much is the resistance of this voltmeter? 400 ohm. And this is 100. And suppose capital R. And this is small r, which is like 5 ohm. 5 ohm then? And this is 21 volt. So this is the circuit. આનું પહેલા equivalent કરવું પડશે ને બધું. So 100 400 parallel gives 80 बराबर ने right बराबर so how much will be the see look here the reading of this voltmeter simply means voltage between the point A and B so if you want to find voltage here આવા સમ આપણે પેલા કર્યા છે ને કરંટ ને ફાઇન્ડ કરીને કરી શકાય do you remember that so find current here how much will be the current how much will be the current so what is that I is equal to 21 upon 85 is that okay or not okay sure so how much is that you get करना 79 માં થાય 3 design and 0 calculator થી करना
0.247
247 okay so this is the current so how much is the voltage for AB now these two are in parallel so પહેલા એનો voltage મળી જશે ને by taking voltage of this correct or not so કરો જલ્દી ફટાફટ so V dash which is equal to VAB which is also the reading of the voltmeter how much would that be 0.247 multiplied by 80 correct or not sure the steps not log now I am assuming you know the concept so what do we get sorry 19.76 okay so that will be the reading fine how will you find the measured voltage done હવે percentage error for percentage error this is practically બરાબર ને when you connect it this is what will happen now what about theoretical 24 ये define करना पड़ता है ना how much 24 20 कर लो check confirm कर लो so find theoretical how much is the voltage between A and B in theoretical it will be current into 100 correct or not and current will be 21 by 105 so that is going to be 20 correct so our theoretical value is and our measured value how much percentage error find it out quickly 12% anybody no out sure 0.2 so 0.24 है हाँ बराबर 1.2 correct so percentage error what's the formula delta I by I theoretical sorry delta V voltage excuse me delta V by V theoretical understood याद आया ना formula for error in percentage so what do we get हमें नो डिफरेंस नहीं लाओ 0.24 upon theoretical is 20 multiplied by 100 so that is 0.24 or 24 by 20 that is 1.2 understood so that's what we get right okay let's go over to the next thing તમને ડિફરન્શિએશન આવડે છે હવે કે નથી આવડતું ચલો તમારા માટે એક સ્પેશિયલ ફિઝિક્સ ક્વેશ્ચન ડિપેન્ડિંગ હેવીલી ઓન ડિફરન્શિએશન I'm going to present it as a question okay but ultimately in the result આવે આપણે યાદ રાખો okay it will be helpful for us maximum power transfer theorem maximum power transfer theorem so here is the problem that we are dealing with suppose someone gives you a cell with some fixed EMF and some fixed internal resistance okay and you want to use this cell to give some power to some device suppose I have a device you want to use this cell to give some power to this device let's say the device has a resistance R. These two are constant. That is, the cell is fixed, nothing is going to change here. Then the question is, what should be R? Question is, what should be value of capital R? If the power given or delivered or transferred, what should be capital R? If the power transferred to capital R is maximum, what should be the value of R? Question is clear?
Yes.
Yes or no? That is, what should be this resistance so that power given to this, current flow to say, will this resistor get some power? What's the formula of that power? Power loss in a resistor or power delivered to a resistor is I square R. Correct or not? I square R. Understood? Okay, so which are the two? If power delivered to that cell is I square R, to the resistor is I square R. If R will be more, will the power be more? If R will be more, will the power be more? Sure? How do you say that? એવું લાગે છે ને કે R ની વેલ્યુ વધારે હશે તો P ની વેલ્યુ વધારે હશે. But there is a hidden problem. If resistance will increase, then current flowing will decrease. Can current be constant in this circuit? Look at the circuit. What will be I equal to? Epsilon upon R plus R. Yes or no? I hope you did it without the formula also. If you have used the formula, no problem, but hopefully you can do it without that. Clear? बराबर है? Epsilon voltage है उधर. R is resistance, so R plus R. So if R will increase, what will happen to I? Decrease. So what is it? Power will say what is it? You realize there is some balancing act going on and it's not easy to judge. बराबर है? It is not easy to judge. That's why we have maths, right, as physics' favorite companion. So when something is maximum, its differentiation is zero. Okay, when something is maximum, its differentiation will be zero. In fact, that's true for minimum or maximum. I don't know whether you know this, but let's write it. Okay, please remember this. We will be using it some other time also. If something or some quantity is maximum or minimum, its differentiation will be zero at that point or for that case. So this is not 100% true mathematically. When you study the applications of derivatives, you will find that this is not true every time, but it is true most of the time. There are some other cases also, but I am not going to the math. Alright, after matter come okay, so if something is maximum or minimum, then its differentiation will be zero. And I gave this a simple example. Do you remember VT graphs?
Yes.
Suppose I have VT graph. At this point, the velocity is maximum. Yes or no?
Yes.
But from VT graph, how do you find acceleration?
Tangent.
Slope of tangent. So your tangent slope of tangent is zero. But also acceleration can be written as dv by dt. So you are telling me that at this point acceleration is zero. So if something is maximum or minimum, its differentiation at that point will be zero. Is that clear? Sure. આ બધું actually graph થી જ આવે છે. એટલે મારે graph લાવવો છે. Even for minimum the same thing would be true. Suppose આવો હોય તો અહીંયા શું થાય? You see that? અહીંયા velocity minimum થાય ને least પછી આમ પાછું ઉપર આવે. Clear or not clear? So this is true for maximum and also for a minimum. I love it. Make sure you remember. Shall I erase it from here?
Yes.
Hello, thank you. Okay, then what do we do? If we know that power is supposed to be maximum, then we will write dP by d capital R is equal to 0. Now, You might be wondering, why am I changing capital R? Because these two are constant. Suppose someone gives you a fixed cell, then epsilon will be a constant and R will be constant in general case. Understood? So capital R is changed. The question basically was, should we connect very large resistance to get more power? Then should we connect very small resistance to get more power? So how much exactly? Should we connect very large or very small or this much or this much? That's what we want to find. What should be the value of a differentiation when zero book in allow answer? Math problem. I will not dip my toes into it. But what the math કરવાનો છે મારે આન્સર નહીં આવે ત્યાંથી આપણે આગળ નથી જવાનું. Hurry up. How to start? Put Power's formula I square R, but then I is equal to epsilon upon R plus R. Put it over there. અને પછી જરૂર પડે તો ડિવિઝન રૂલ કે જે કંઈ થતું હોય કરો. ઓકે. Okay, चलो फटाफट. Here, so dt by dr, so power is I square r એટલે epsilon square r upon r plus r whole square. Okay, its differentiation should be 0. Fine. Epsilon square is a constant. Put it out. Put it by the 0. પછી આટલું બચે division rule. Okay or not okay? Yes. So we should write numerator's differentiation means r differentiation. 1, okay, into denominator, so 1 into r plus r whole square minus minus u dv by dr, and r no differentiation, so that is going to be 2 times r plus r into 1 chain rule thing. Okay or not okay? Yes. Fine. Expand કરીને કરવું હોય તોય વાંધો નહીં, તો એક થઈ જશે બરાબર, but this is easier, shorter, divided by. Now I have something in division, that will be r plus r whole raised to 4. પણ એ લખવાની જરૂર નથી કેમ, equal to 0 is only by multiply. Did you get that? Yes. Sure. Okay, હવે આને સોલ્વ કરો. તો એક r plus r કોમન દેખાય છે. What's remaining behind? r plus r minus r 2r, okay, is equal to 0. So therefore r plus r is equal to 0, or r minus capital R equal to 0. First bracket, second bracket. Alright? Okay or not okay? Yes. Now this is nonsense. The resistance cannot be negative, not in conductor that way. So this is not possible. And the other one is capital R will be equal to smaller. So that's the condition. Right? So when you have got a cell with a constant EMF and a constant internal resistance, then the external resistance, when it becomes equal to internal resistance, when the external resistance becomes equal to internal resistance, then the power delivered to this will be maximum. Understood? The power delivered to this will be maximum. Okay? Fine. Let's solve a question based on this. Ready to start? Yes. Any queries that you have? Maths or either पूछ ले दो. A differentiation no problem है तो तुम्हें. Anyone? Okay. So suppose it says that find maximum power that can be obtained from a 6 volt 1 ohm cell. What is all? Use the relation we have derived. Draw a circuit first of all. What's the answer? नहीं उड़ा दीदो क्यों? Nine. Yeah.
9 children.
What? Nine.
9 children.
46 बताओगे मैंने? Okay. Let's draw the circuit. To get maximum power, how much external resistance should be connected? How much external resistance should be connected? One. Is that clear?
Yes.
आज तो derive करो ना अपने. What if? So now how much is the current?
3 ampere.
3 ampere. Okay or not okay? The current here 3 ampere. So how much power is given to this external resistance? P is equal to I square R. Only 9 into 1. That is 9 watt. Clear or not clear? Okay. Options में कोई काम को danger नहीं. जैसे options आए कोई नहीं. ત્યારે બહુ dangerous છે આ તો. Because it's so silly. 6 1 એવું જોઈને તમને હા કરી નાખો ચલો અને બીજો ઓપ્શન આવી જશે તરત જ. Right? Okay. So this is it. થોડા આગળ જઈએ. આ ટોપિક. Suppose this is, let's say 12 volt and this is 4 ohm and this is 16 ohm. Okay. And let's say this is up. तो चेक कर देंगे आणि जरा व्यवस्थित सरस क्वेश्चन. Can you find maximum power delivered by this cell? Does cell have internal resistance? No. They say your true cell. Okay, then does not have internal resistance. Especially designed to bring you out of the always use formula behavior. बराबर है? Does this cell have internal resistance? No. That's the biggest hint. ये तो मने बुद्धि भी है. केमिस्ट्री मने. आइडिया बता दे. Evaluation नो के टेस्ट नो लेते थे पहले. બીજું કે નહીં નીચે આવે ને માઇન્ડ ટેસ્ટ લખવા આપી દેવાય. હા આવડે તો શું ભણેલું છે? મેગ્નેટિક ફીલ્ડ લોરેન્ટ્ઝ ફોર્સ શીખવાડી દીધું. અરે વાહ, મારું કામ તો જોડે આવે. હા તમે નહોતા કેમ ક્યાં હતા? પનિશમેન્ટ આવી દીધી તો પણ ટીચર હતા. એ તમારો ટીચર તો ધ્યાન આપવું પડે. di square by dr. So r into di by dr. Correct concept. But there is actually no need to do differentiation for solving this question. Let's see how. Does this cell have internal resistance? No. Correct or not? So do you realize that the power delivered by cell will be equal to I square into R equivalent? Yes or no? Is this clear or not clear? I square into R equivalent. What is R equivalent? The resistance of all that is connected. But then because there is no internal resistance, do you realize that I can also write it like this? Yes? No?
Yes.
Sure?
Yes.
Absolutely?
Yes.
Okay, then I, in this case, I will be equal to epsilon upon R equivalent because internal resistance is not there. Clear? Fine? So, ये मूकी दो एक एक कट થઈ જશે ને. Now, epsilon is a constant or not? How much is its value? Where? Given in the question. What about R equivalent? Is that a constant? So, what does R equivalent depend on? Capital R. Is it fine? R equivalent આ તો બધું ફિક્સ જ છે ને. R equivalent only depends on capital R. Sure? Okay. Now look at this power delivered by cell. For power delivered to be maximum, R equivalent should be minimum. Zero તો નહીં થાય. Zero તો possible નથી પણ minimum. Yes or no?
Yes.
Sure? Absolutely. Now, for R equivalent to be minimum, what do you think should happen to capital R? Should it be more or less? Resistance વધે તો equivalent resistance વધે કે ઓછું થઈ જાય? If individual resistance will increase, will equivalent resistance increase or decrease? Increase or decrease? Decrease. Increase. Who says increase? Okay. Not so confident? Increase or થાય ને. If individual resistance will increase, equivalent resistance will always increase. Is that clear? Check કરવો હોય તો કરી દો. પહેલા અહીંયા મૂકો 8. તો શું આવે? For example 16. 16 8. 8 plus 4 12. 12 આવ્યું. હવે અહીંયા 8 નો મૂકો. Let's say you put 16 here. તો હવે શું આવે? 16 8 24. 24 16 parallel માં શું થાય? 24 and 16 parallel. 10 to 2 by 2 plus 2 6 by 1 by 2. 1 into 2 by 3 was 5.3. Only these. Okay, 16 line. 16 line है ना? 24 16 2 into 3 6 upon 5 is 1.2 1.2 into 8 1.2 into 8 9.6 9.6. So these two together is 9.6 and now this is 4. So what do we get? Why do we want to take it? What is that? Obviously, if this will be more, if R will be more, R equivalent will also be more. So to get maximum power, capital R should be more or less?
Less.
Less or more?
Less.
Sure? આમાં તો કોઈ confusion છે ને. આમાં ક્યાં differentiation is there? You get what I am saying? It's a straightforward relation that if capital R will be less, R equivalent will be less. If R equivalent is less, the power will be more. So capital R the smallest value શું મુકાય? What can be smallest value of a resistance? 0. Sure? So put it 0 and get the answer. Some of you would be thinking, solve the super formula directly. You will not know. But it's the sequence here. When to use the formula and when not to use the formula.
34.45 watt.
16 by 3 plus 4 is 28 by 3 12 upon 28 by 3 is 36 by 28. 36 by 28 अरे ना मैं फोटो याद करूँ स्क्वायर करना भूल गया साथ ही
15 by 4 3
what do we get 16.16
15 by 4 15.143
okay चलो कंप्लीट करो ना भाई so we are putting this as 0 बराबर ने we are putting this as 0 so now we should say 8 and 16 in parallel is 8 into 16 upon 24 so that is 3 so 16 by 3 and plus 4 so 16 by 3 plus 4 is 28 by 3 okay this is equivalent resistance over here મૂકી દો so epsilon square is 144 upon 28 by 3 so that can divide time you know 4 is 7 and this is going to be 36 okay or not so 108 upon 7 so that is 1 38 I have the 5 40 I have the 4 2 and so on and 4 to 8 I have the 40 all right if you think about it carefully isn't it easier than the differentiation and all that बहुत easy आज क्वेश्चन में चेंज करना है तो अंदर इंटरनल रेजिस्टेंस की देखो सपोज 2 ohm
R equal to R equivalent is
तो R equivalent equal to 2 ohm क्यों થાય आप होते 4 ohm थे how can R equivalent be 2 ohm बराबर ने is it possible that R equivalent is 2 ohm yes or no तो પછી શું કરવાનું just take the smallest you'd have to differentiate it by writing everything પણ r ની વેલ્યુ નથી એટલે પાછું એને એવી રીતે સિમ્પ્લિફાય કરવું પડશે સમજ પડે છે just like we did earlier કરતા નહીં હો ખાલી તમને કહો છો આવી રીતે કરે બહુ લાંબુ થશે because all the values are very tricky same thing dp by dr equivalent or dp by dr equal to 0 એવું પણ આ બધું પહેલા સિમ્પ્લિફાય કરીને લખવું પડે 8r sorry 8 plus r into 16 upon 16 plus 8 plus r plus 4 આવી રીતે લખવાનું is that okay or not okay પછી એનું differentiation long way to go for power right okay when okay so you have been handed over an assignment now finally this year let's start solving questions who is the one yeah go on બે લઈ લીધી બે વાર સોલ્વ કરવા માટે okay first one in presence of applied electric field evacuated in a metallic conductor decide come on theory याद कर देना कि भूल गया तो what do you think
D
4 electrons move randomly do you remember random motion never stops but gradually the electrons will drift will they drift in direction of electric field no opposite why opposite because electrons have negative charge so they will move or they will be forced in direction opposite to the electric field clear okay sure first second potential difference applied to an X-ray tube is 5 kilovolt. Don't worry too much about X-ray tube. Exotube is basically like a vacuum tube. આવે છે તમારે કેમેસ્ટ્રીમાં આવ્યું છે કે cathode ray tube ને બધું, right? It's similar to that. So what is happening is that electrons will be moving between two plates. Do you understand? Electrons will be moving between. Understood? So what is the potential difference between plates? How much is the potential difference? V is equal to 5 kilovolt. Okay. And current through it. So obviously this would be connected to some kind of battery or something like that. And current flowing through this circuit or this whole thing. And અહીંયા જેટલો થાય એટલો જ અહીંયા flow થાય. Do you realize that? Yes? No. Yes. Because if electrons will come from here, they will go up there. Right? In the whole loop, current should be same. So how much is the current flowing? How much is the current flowing? 3.2 milli. Everyone understood that? Then the number of electrons striking the target and target. What's our target? Okay, number of electrons striking the target is. So what do we have to find? Small n per second. And I find not capital N number of electrons per second. Current is given. Is there a way to relate this with this? What is the general, basic meaning of I? I is equal to Q by T. Right? And if n electrons are hitting here, then how much charge is flowing? Ne. Correct or not? So what should I write? This is equal to Ne by T. Charge flowing is of n electrons. So n electrons have a charge n into E because one electron has a charge E. Fine. So Q is Ne. So Ne by T. That is I. Can you find this now? Number of electrons striking per unit time. એમાં વોલ્ટેજ નો શું રોલ? કંઈ નહીં. Not for calculation. હવે કેલ્ક્યુલેટર મૂકી જો. બરાબર ને? થોડુંક તો જાતે પ્રેક્ટિસ કરો તો આવે. કેલ્ક્યુલેશનમાં કંઈ નહોતું. એક મહિનો તમે કરો ને કેલ્ક્યુલેટર વગર, પછી તમને કેલ્ક્યુલેટરની જરૂર જ ન પડે. એવું લાગે છે કે હા લઈ લઈ ચલો. નેક્સ્ટ કરો મતલબ થિયરી તો બધી ચાલી જ ગઈ તો અમારે થાય એટલે બરાબર.
હોમોજીનસ એટલે સેમ એવરીવેર અને આઇસોટ્રોપિક એટલે કંઈ ડાયરેક્શનમાં ઉપર નીચે બધી બધું હરખું છે એટલે ઇન શોર્ટ યુનિફોર્મ. ઓકે, uniform in properties, ખાલી cross sectional area is different. Okay.
A. Are we getting A here? Okay, let's go to the next question. Short. આવું કંઈક આપણે કર્યું હતું યાદ છે? ક્લાસમાં મેં કરાવ્યું હતું. ખબર નહીં હોય એક્ઝેક્ટલી છે. Electric current passes through non-uniform cross section. Means the wire is thinner at one place and thicker at another place, right? Okay, made of homogeneous and isotropic material. What that means is the material is uniform. भले area अलग-अलग है, but the material is uniform. Same density, same resistivity everywhere. Okay. If the JK and JP are current densities and EA and EB are electric field intensities. Intensities તે જ અલગ જાણે કોઈ disease નું નામ હોય. Sinusitis, intensitis, so they intensitis. બરાબર ને? Meningitis. So what do you think is the answer? Same શું હોય at every point. If current is flowing like this in a material, what will be same? Current will be same. Is that okay? So IA is equal to IB. પછી આગળ જવાનું. So which current density will be more? At A will be more because there the area is small. Understood?
Yes.
Okay, if current density is more, then electric field will be more or less? More or less? More. Why relation? J is equal to sigma into E. Okay or not okay? Fine. So that's about the third one. Next question. Finish for concept based only. बराबर ने? Two materials are given. Which two? One is copper and germanium. Okay, copper is metal, that is a conductor. Germanium is a not metal, it's a semiconductor. Germanium is a semiconductor. Silicon and germanium are two elemental semiconductors, right? Okay, so it is cooled from temperature, room temperature to 80. So we are decreasing the temperature, correct or not? So decrease the temperature, the metals must do that. What increases? Resistance and resistivity will increase. And semiconductor must decrease. You remember that or not? Yes. Semiconductor must decrease and metals must increase. So which option? C. મને એવું થાય છે કે આખું તમને હોમવર્કમાં ચોંટાડે બરાબર ને ના કઈ વાત વિલ ડુ ઇટ ટર્ન ઇટ ઓફ